Thank you. Good morning, everyone. And sorry about the room confusion, 205, 306. We are also running around. But glad you are here. And the first day of the conference, so super excited. So let's go and learn about Databricks Serverless, what that is. My name is Nikhil Jatawa. I'm a product manager here, part of platform team. Along with me, we have Aaron Davidson. He's a principal software engineer, Uber technical lead for the serverless platform. And we'll have a Matt Ryan presenting about how they are using the serverless platform. In this session, you will learn 4 things. First of all, I want to talk about why we decided to work on serverless platform. What were the motivations, feedback that we were getting, and how we are answering those challenges with the serverless platform. Then Aaron will come and talk about how we are designing the serverless platform, the architecture of it, and as well as how we are implementing security inside the platform. We want to make sure that the data is protected, and Aaron will do a deep dive. And Matt will talk about how they are leveraging the serverless platform and really driving the meaningful impact for their customers. And finally, we'll finish this conversation with some of the next things. How can you get started with this, with the serverless platform? With that, just learning the click here. Before we go deep into serverless platform, let's talk about Databricks SQL. As you saw earlier in keynote, best warehouse is a lakehouse. What Databricks SQL allows you to do is that it allows an analyst to do an ad hoc SQL query. They can also do dashboards or connect to third-party BI tools when they are trying to use this SQL product. When you are using this SQL product, so far what you have to do is you have to create something called as endpoint. An endpoint in the background is leveraging clusters. So in Databricks, cluster is a concept where if you want to run a query, if you want to query some data, look at metadata, you are creating clusters. And these clusters are performing the compute tasks that are required to do the computation. So this was the traditional interface of the Databricks across all the Databricks products so far. When we look at our customers using this Databricks SQL in a classical way, and also when we look at other customers who are using machine learning or a generic compute workload, there are some challenges that we saw our customers go through. Specifically, some of the challenges are that they are non-trivial in terms of configuration. When you are trying to create a cluster, you have to figure out the instance type. If you want to select DBR version, should you use AutoAZ or not? So there are multiple choices our customer has to go through before they create the compute environment. Lastly, it takes multiple minutes to start this environment. So imagine you are going through all this complex setup, and you have to wait for 3 to 5 minutes before the environment starts. And this is what we are seeing across all the customers. And when you are trying to do this thing, you're also doing a complex pool capacity management with the cloud provider. So this creates significant burden for our customers. And these challenges, they lead into some behavior that we are seeing across all the customers. For example, we are seeing long-running clusters to avoid the startup time. We are seeing customers over-provision the capacity because they don't know if there will be enough compute environment to serve their spikily and bursty workloads. And in addition to that, if you think about all these different environments, these are differentiated tasks, but underneath they are using the same clusters. So they are not differentiating, meaning is that they are not really gaining the benefit of the platform for their differentiated tasks. These challenges lead to behavior, and they lead to pain points. The pain points are that our customers are paying for idle resources. There's a significant increase in the cost for them. There's admin overhead. And most importantly is that because when they are waiting for those environment to boot up, this impacting the productivity of the end users. This is where we are solving these problems with the serverless platform. There are 2 key benefits here, or there are 2 key features. The first one is this environment starts instantly. It can start, scale up, scale down within seconds. Not just that, this provides a completely managed environment to our customers. Some of the behavior and some of the impact of these features is that now you don't have to, our customers don't need to have a long-running clusters. You can demand an environment that can start up within seconds, and you can, as soon as the work is done, you can return the environment, and that you don't have to then over-provision for the capacity. And lastly, you don't have to worry about managing the capacity with the cloud provider. That's something, because it's a managed environment, we do it on behalf of our customers. This behavior will lead into some impact that we are seeing across all the customers, where now this will help our customers reduce the cost, and this will also help increase the productivity for our end users. Now, what are the capabilities of this serverless platform? There are 3 key features that are there. The first one is there is a pool of environment, a pool of Databricks clusters that are always running, and they are not assigned to any customer, so nobody's paying for it. But this pool are the managed servers or managed environment, right, that we do on behalf of our customers. These are elastic, meaning is that this can scale up, scale down, this can meet your bursty workload. And this whole platform is built on 3 layers of security isolation. Aaron will do a deep dive into this security isolation, but all it does is that it allows you to protect your data and make sure that the data stays where you want it to reside. We have implemented a machine learning model. What we do is that we make sure that we have enough capacity to meet all of our customers' demand. And this machine learning model is always learning, it's predicting, and that's how we can pre-provision the capacity and make sure that our customers can get this access to instant and fast compute. Now let's talk about what kind of performance you can expect. This is where we were before non-serverless started. The first query performance used to take 5 minutes. Now, 5 minutes is not acceptable. That's how some of our customers, they implemented a concept called as instance pool. With instance pool, you can get down the startup experience or the first query performance down to 1 to 2 minutes. So this is what we have seen customers do. Instance pool is very expensive for our customers because you are maintaining a warm environment for you to run. This is what we have seen some customers do. That being said, when we get to serverless, the current performance that we are seeing across all our customers with less than 10 seconds. Not just a startup, or you can now expect the first query performance in less than 10 seconds across all our SQL workload. And we are not stopping there. There's more work that's happening that will take this down to first query performance of 2 seconds by the time we GA this service. So there's a significant improvement going on across the company to make sure that we are providing this environment quickly and efficiently to you. The reason we are putting so much stress on a startup experience is that imagine if you can start up fast, you can shut it down fast. And this allows you to actually save the cost and make sure that you are paying based on your consumption. Now, you may be thinking, well, this benefit sounds amazing. Will this cost you more? The answer is no. We are in a public preview on AWS. We have hundreds of customers using it. And this is where we are seeing across all the customers is that customer can save 20 to 40% in total cost of ownership by just switching to the serverless environment. In this simulation, what we did is that we looked at one customer who we have been working very closely with since very early days of serverless. Typically, they use medium-sized SQL warehouses. For a single warehouse, it used to cost them around $37,000 to run in a year. This assumes that you are running this warehouse 8 hours a day. What this customer did is that they just moved this one warehouse, one endpoint from non-serverless to serverless environment, and they saw 35% reduction in total cost of ownership. Everything, just imagine the power of this one. Customer didn't have to change anything. All they did is that just convert one warehouse from a classic non-serverless to serverless. And by doing so, they were able to get the benefits of serverless environment, instant compute managed environment, as well as reduce the total cost of ownership. And this is what we are seeing across all the customers that are there in the public preview. Now, so far, what we are seeing is that we are comparing ourselves. We are comparing serverless offering with the non-serverless offering. Let's see how this stacks with our competition. This plots, it's a 3-dimensional plot. On the x-axis, you are looking at the startup time, startup performance. On the y-axis, you are looking at the query execution time, mainly the performance of the engine itself. And the color coding talks about the total cost of ownership. You all heard about the keynote, the TPCDS benchmarking. So serverless platform underneath is leveraging the same Spark engine. That's one of the most performant Spark engine out there in the market. So what it means is that it makes the serverless offering one of the best out in the market. On the x-axis, there's the startup experience. We talked about how we are making continuous improvement, and we are at the best industry leading in terms of startup experience as well as scale up and scale down experiences. And when we see this across all the customers, we are seeing is that we can save significant cost for all our customers. So with that, Aaron will go talk about architecture and security.
So to begin with, I'm going to recap the goals of serverless. Actually, a slightly different light than Nikhil's talk. So in Nikhil, he talked about cost as a primary goal and fast startup as a primary goal. But actually, the most critical thing that we can achieve, that we can improve upon in serverless, is improved reliability. And through the mechanisms we use to improve reliability, we can also happen to reduce TCO, total cost of ownership, while also reducing the management overhead. At the same time, of course, we need to maintain or improve the Databricks security posture. You're trusting us with very important data. I'm going to talk about 3 key mechanisms by which we do all this. Instance type selection, warm pooling, and administrative simplicity. So for anyone who's run a big data workload, you know that instance types are quite critical for reliability, cost, and performance. Reliability, both in the sense of, are there enough instance types in the right region, of this particular type in the right region, in the right availability zone, but also in terms of, does my workload crash? So it's very important for reliability, and of course, cost and performance matter a lot. And if you go to, let's say, the Amazon page for instance types, you'll see, a nice list of instance types. Here's like what you'll see. You see, okay, 14 instance types. I can kind of like go through these, scan through these, figure out what I need. Then you look towards the left on their page, and you'll see, oh, actually, this is just the general purpose class, and I also need I need to think through compute optimized, memory optimized, GPU storage, which is like the best for my workload. And suddenly you realize that actually selecting the right instance type for a particular workload is actually quite challenging. Additionally, keeping up to date with instance types. The cloud providers are constantly releasing new instance types, and they tend to be better at price performance, and so it's important to adopt them quickly. Databricks can help with all this. We can simplify it. We can provide recommendations. We can provide defaults. But critically, because the actual VMs are launched in your account, we run into capacity limits from your side. So, what capacity have you provisioned with Amazon or with Azure, with Google? And if we just switch to another instance type under the hood, might cause crashes for you, or it might cause you not be able to scale up. Or reservations, cost structures. What kind of contracts do you have with the cloud providers? That might be instance type specific. We might see a reduction from our calculations, but it might end up leading to a higher cost for you. So in the serverless architecture, we don't even offer instance types. We just say, give us a general size, like small, medium, large, for your pool. We leverage benchmarks, as the one Nikhil stated, to identify the best cost performance. We just run it over all the instance types, and we figure out what the best is for the cost performance ratio. And because we manage the capacity and reservations, that enables us to quickly adopt new instance types, Graviton, I4I, that kind of stuff in Amazon. And also to leverage a heterogeneous instance pool for availability, which is also quite critical. New instance types tend to be lower in the total capacity, so you need to combine that with older instance types, or maybe for spot instances. And additionally, we work with the cloud vendors to understand the regional and AZ capacity. We have weekly meetings where one of the main topics is, when are the new instance types going to be available? When can we use them? When can we give it to our customers? So this is all stuff that we can do for you in our account. Regarding warm pools, Nikhil actually showed this feature called instance pooling, where a user can, in their account, create a pool, set a minimum idle, set a maximum capacity, and an instance type. And then you can provision like an extra capacity of VMs that are unused. And this offers faster startup and more predictable startup time. So if you have jobs that you want to run regularly and complete on time, this is a great feature for that. But the major problem is you, of course, pay for these instances. Databricks doesn't charge you like DBUs, like our unit, but of course, Amazon or Azure will be charging you for the VM fees. And so now immediately you have to come up with the exact dollar amount that you're willing to pay for faster startup and more predictable latency in comparison to the VM pooling cost. Additionally, management is complicated. How do you pick these numbers? What is the right minimum idle, and how does that change when your workloads change? And how do you pick the right instance type? We just talked about that. That's challenging. So in serverless, we pool by default, and we can do so because we can amortize that cost across many customers. So we can offer the same benefits, faster startup, as Nikhil showed. We can offer even predictable performance because we can amortize the bursts of multiple customers, sort of average it out, and have one large pool. And of course, it's our responsibility to optimize the pool to minimize the instance. It becomes our responsibility, not your responsibility. In other words, to figure out what the right sizing, what the right instance types are, while still providing excellent user experience. And the last reliability feature I want to mention is the administrative costs. So anyone at an enterprise, oftentimes what you'll find is that things like VPC and VNet sliders, it seems kind of esoteric, but when you run in your account, you have to bring a VPC. And if you're in an enterprise, they have to assign some sort of IP range that Databricks can use. And oftentimes they'll have pre-existing networks that they need to connect to and connect within. And so just managing which slider, what the IP space that they can allocate to us can be actually surprisingly cumbersome. So anyone who's been trying to integrate Databricks into enterprises will almost always encounter this. Too small a slider range, and we can't scale up to a large number of instance pools. Two is too large, and it might interact with your network administration. So in serverless, we run those in our account. The next one is on account and subscription charting. Another surprising thing when you're running at scale of, let's say, thousands of VMs for very large workloads, you'll find that there are limits in Amazon, in Azure, that are at the account or subscription level, things like how many network interfaces you can attach per minute. And eventually you just run into a hard limit that they can't increase. And the recommendation is to build a new AWS account, build a new Azure subscription, start charting your deployments. That is the recommendation, that is what you can do, but it's pretty challenging to do it. And so in the serverless model, we do that, and we do it for you. Okay, so those are the three mechanisms I wanted to talk about that improve reliability while also reducing cost to you and reducing the management burden. Now I want to talk about, kind of convince you or show you how the security architecture works within the serverless model so that you know, like, is it okay that I actually move the compute from my account to your account? So in the classic architecture, classic meaning running VMs in your account, we start with users on the right-hand side. And so that could be an individual user, it could be an application like Tableau. It connects to the Databricks data plane. The control plane. The Databricks control plane is a multi-tenant control plane. It offers like our notebook service or job service or SQL service, all that stuff. That's great. Any actual commands, any like important stuff that needs to run and access data will go to the data plane. That's where the Spark workload, that's where the SQL workloads are actually executing. And so that's, Spark is there, it's a distributed system, it'll access your cloud storage on your side. So in Classic, this is what it looks like. As you might expect, in the serverless architecture, that data plane component moves into the Databricks account. The storage remains in your account, of course, as part of the Lakehouse paradigm. So in this, you see two changes here in the server. So one, we have now an unallocated pool. I mentioned that. We always have an instance pool. But also we have multiple clusters. Now these are clusters that are shared across, the clusters individually are not shared, but the different clusters are now sharing this red bucket. They're in the same data plane. So even for different tenants, you have different clusters in the same data plane. So how we secure that is we draw a box around all of the clusters for one tenant, one customer, and draw a different box around other tenants. So these are a security boundary. It's a security group boundary, but also just a full isolation boundary between these tenants. So unallocated pools are shared, but the individual clusters are within this boundary. How do we implement this boundary? So if we look at it from the perspective of a virtual machine, so a single EC2 instance or Azure machine, that kind of thing, and we say, how do we actually a cluster is composed of multiple VMs, but if we look at for a single VM, what we can see is we start with the cloud provider, we allocate a VM, we launch a VM. That goes into the unallocated pool, the warm pool. Then when a customer needs it, we assign it. Okay, everything seems pretty normal here. Once the tenant is done with their workload, we have a choice. We can put it back into the unallocated pool. That would be the most efficient, cost-effective thing to do. But in fact, we don't do that. And instead, what we do is we terminate the VM entirely. Okay, so in other words, there's no VM reuse. The memory, disk, other devices for that VM are just totally recycled, eliminated after the compute is done. So it's totally ephemeral. And instead, an entirely new VM will be provisioned into the unallocated pool. Okay, so there's no VM reuse. VM boundary is sort of our isolation structure, which is actually the same as in the classic model. Looking into the VM, because it wouldn't be sufficient just to say, okay, you don't reuse VMs, but what is on the VM? So briefly to describe that, we have here a tenant one VM. There's the workload, of course. That could be a SQL workload today. In the future, as Nikhil might say it in a little bit, it could also be a Python or Scala workload, that kind of thing, our workload. That's kind of arbitrary code. So we do run that in a container. We have seccomp policies on privileged containers, limited syscalls, you can make all that stuff. But because it's still container, same kernel, we expect that breakouts are feasible. And as a result, although there are agents running on the machine to do things like availability, health checks, security monitoring, none of those agents have credentials or capabilities that would offer cross-tenant data access. So there's no way to phone home to the control plane. There's no way to reach out to another tenant directly. So just wanted to point that out. There is a container boundary, but really the VM boundary is the true isolation mechanism. Once you're on the VM, of course, there's one more thing you might want to worry about. So if there's an attacker in tenant 1, can they reach out to tenant 2 VMs? And the answer is no. We draw a network security boundary, a cloud network boundary between different tenants. So clusters or VMs within the same tenant can talk to each other. You need to. Spark needs to be able to do distributed computation. But between a VM from tenant 1 cannot reach out and talk to a VM from tenant 2. Just stepping away from the VM level. So I hope you've seen at the VM level how an attacker within one VM cannot directly break out into another VM and cannot attack another person's workload. The last thing we need to understand is the broader network infrastructure at play. How do requests flow more broadly outside the scope of a single VM? So first of all, we have how do users access the data plane. All data goes through the control plane. That's important. That means we can have one unified authentication authorization layer in our control plane. All actions are logged. And so all user to control plane actions are TLS. Typically it's open to all, but you can also restrict it further with IP access lists for a VPN or private link if you want to ensure that your workspace can only be accessed from a specific VPC or VNet. That's also possible. But that is actually the same as classic. There's no difference. I just want to point out that there's no direct way to get to the data plane. It all has to come through the control plane. The second component, which is kind of new, is how the control plane talks to the data plane. This is all, and vice versa, this is all MTLS, mutually authoritative TLS. That's actually the same as classic. Importantly though, the workers are always private, so they don't have public IPs, they're on the private network. Communication goes to the cloud provider backend network routes. So you can actually do that in classic, but in serverless, we do it by default, and so it's secure by default, so you don't have to configure it, we just do it. And finally, how does the VM actually communicate to storage? That's quite critical. The VM is totally ephemeral. It loads data from storage, runs some processing, and then dumps the data back to storage. So how does it actually do that, get access to storage? So in the AWS example, a customer can provide us an IAM role, our control plane, to be used on their clusters. The IAM role will be assumed by our control plane, and the temporary credentials that are resultant from that will be placed onto the VMs. So in other words, the customer's VMs have temporary credentials for their role, and obviously no other VM would have access, so we talked about why that's secure. And then when they connect to cloud storage, as long as it's in the same region, it will go through an S3 gateway, it'll go through an Azure service endpoint, that kind of thing, and remain in the private backbone. So all communication, especially if you start from private link, then all communication will remain totally within the cloud network backplane. So that's pretty cool. So with this, I've kind of described how the security architecture on Databricks Serverless is as good, and in the default are even better than in the classic architecture. And with that, I'm going to introduce Matt to talk about one use case at Kythera.
Slide this over here. Okay, so first, thank you, Aaron and Nikhil, for the opportunity to talk to you a little bit about our experiences with serverless at Kythera. First, a little bit about Kythera. We help life sciences and healthcare organizations get to business value fast. We see organizations that use healthcare data struggle with the volume and to get actionable insights and value from the big data. While this data is very exciting, but from a clinical and commercial standpoint, we find that it's not really ready for what we consider to be answer ready. So we source large-scale industry data, we enhance it, we do some repairs, we add some dimension to the complex healthcare data to make it more consumable. And in the process, we provide analytics to improve the insights and accelerate innovation. Through our partnership with Databricks, we were the first healthcare OEM with Databricks. We offer our branded instances called Wayfinder, which we enable our pipelines to perform the increased value on those data investments, 8 times faster results, richer, more granular insight. Oops, I should move this. In short, we help healthcare and life sciences organizations solve their biggest, toughest data problems fast. And with Wayfinder, we can get a new client up and running, accessing our data in a matter of hours as opposed to after a long implementation project. And since we've been an OEM partner with Databricks for a long time, we've had the opportunity to work with a lot of previews and development versions of things, serverless being one of them. And so we've been using serverless for quite a long time for our own internal data discovery and SQL access, and BI workloads as well. And recently I've started rolling it out for some client product offerings as well. Years ago, we actually tried to start this with a Snowflake implementation. The proprietary data formats and a surprise bill we got there quickly sort of made us decide for an all Databricks solution. Internally, it has been very helpful for us to reduce our EC2 spend. We have data analysts, a large team, and they're hitting it from all different directions, BI tools and whatever. And we've found that we're more closer to that 40% savings on costs because it's a lot easier to track and manage that, and that's what we've been finding. What I'll give you a quick show here now is a client-facing tool that we call the Patient Cohort Builder. You can see here, it's for life sciences clients. It's accurately identifying the market and validating its size are very critical in commercializing a therapy. So the typical user of this would be what we'll call the citizen data analyst accessing data casually. So someone who's skilled with BI tools, SQL select statement, knows the data well, knows the business requirements really well, but for sizing up partitions, parallelism, skew, shuffle, some of those things are just technical details that sort of get in their way of getting answers. So let me pop over to here. Not a touch screen. So what they'll see, there's a lot of cool pipelines that go behind this to pipeline the data, get it into the dashboard. But what the client will really see is this dashboard. This is pretty hard to wow you with just a dashboard, but you can see the fact that cluster is ready and running and already rendering the dashboard is not trivial. For a user who might be coming in and looking for data here and there sporadically during the day, to wait for a cluster to start up, even 2 minutes, is a significant pain point. So especially when they're having to do it several times a day. Now, it's true we could have just had a pool or some big cluster in the background ready for when they're going, but from a budget standpoint, that doesn't make any sense for their use case. So what serverless enabled is the ability to bring big data compute power to the user exactly when they need it and only when they need it. So in the case of this user who is working with this dashboard a little bit, when they're done with it and they move on, those compute processes move off their meter and potentially flow over to another one of our clients who is perhaps more comfortable working in Tableau. And now they're paying for those resources, getting that same big processing powers immediately. And when they turn it over, maybe a client who's actually interfacing through Power BI. So our data is our value, and we're able to sort of make it available through their Wayfinder instance and also consumable the way they're most comfortable. So I think that serverless is a very elegant solution to a very specific problem of, in a cost-efficient way, bringing big data processing power to only when a user needs it and as soon as they need it. So with that, Nikhil, thank you. Appreciate the time.
Thank you. So what we saw is that 3 things, why we decided to work on serverless platform, how we are architecting it, how we're implementing security, and Matt gave an amazing example how he's processing gigabytes of data with serverless platform, serverless warehouses in the background instantly. What's coming? We are in a public preview on AWS as of today. That's not about it. As you can see, it's a big timeline. We'll be on Azure public preview in July. And this serverless platform will be GAing by end of this year on both the clouds, AWS and Azure. GCP is also coming. Google Platform, if you are a Google Platform customer, it's also coming in the near future. But that's not about it. As you can see in this conversation, we are talking about serverless platform. And so far in this presentation, we talked about instance type, which may or may not be related with the SQL warehouse solution. Also, we talked about SQL, Databricks SQL, where we went a deep dive. So what we are doing with serverless platform is we are expanding this benefit and taking this beyond SQL. Meaning is that if you are using jobs, if you are using generic compute, machine learning, everything will be supported with the serverless platform. So what it means is that all the database product will have the serverless platform, and you can get these 3 benefits. It's going to be very fast to scale up, scale up, scale down. It's going to be completely managed, and this will help you reduce the cost for all your compute needs. So what should you do now? It's already available on AWS. Go to your account console, flip the toggle for the serverless compute button. Then go to Workspace, flip the toggle, and start using it right away in the Databricks SQL on AWS. If you're on Azure, go to and submit us a request. Once we launch this on Azure next month, we can onboard you as soon as this is available for you to use. And lastly, talk to your Databricks representative. We are happy to support you or answer your questions in terms of your security or whatnot, and make sure that we are addressing all your concerns as you move to your serverless platform. With that, thank you.
Okay, I think we've got time for a couple of questions. If anyone from the floor, this gentleman here.
One for you, Nikhil, and one for Aaron.
Yeah.
The 70 cents per DBU.
Correct.
Is that based on Graviton processor, or is it just guesstimate?
The question is, the serverless pricing per DBU is 70 cents per DBU. That's what the serverless price is, and that includes both Databricks SQL price as well as underlying compute infrastructure price. Right. So the question is, does that include Graviton or not?
Yeah, because that is a better price performance.
Correct. So this is where it goes back to, as a customer, you shouldn't be thinking about Graviton, R instance, i3 or whatnot. This is Databricks' responsibility to provide you a consistent price performance across any instance type. So as a customer, you shouldn't be thinking, do I use Graviton or not? We'll provide you consistent price performance at 70 cents per DBU.
So that means, like, because Graviton provides better price performance, probably about 70%. So does that lead customers to go back to Classic, because I save a lot of money rather than paying 70 cents on serverless? I can spend 20 cents on my server and 10 cents on administration. Still, I save 40 cents.
Correct. So just to repeat, because there are people online, the question is, with Graviton, you might be able to finish your workload faster, so it might be cheaper, 70 cents versus 20 cents. That's the hypothesis if you use Graviton. So the thinking here is that with serverless, if suppose you are getting those performance with Graviton, we want to make sure that the serverless performance is equivalent to classic performance. So that's the performance is always matched with the classic. So there shouldn't be any difference from the performance perspective. There shouldn't be any difference between classic and serverless. All serverless does is it just starts fast and scales fast, and it's a managed environment.
One for Aaron, right? Aaron, the VM, as soon as the job is done, you said it gets terminated. It doesn't go back. Right?
Right.
What is considered as a done? Like, let's say I'm running a SQL statement. Is that done immediately, or is it done after 10 minutes? The reason I'm asking is I lose the cache. The second query that comes in, it'll have to redo the work. So what was the rationale behind terminating the VM?
Cool. Yeah, thanks for the question. So around terminating the VM, when do we do it? So the goal of the discussion was to say that we terminate the VM before giving it to another customer. There can be a configurable period before we terminate it. So it's as soon as the SQL query ends, we actually don't terminate it. There is a grace period. It's actually configurable. So I think the default's 5 minutes. You can downgrade it if you like.
Thank you.
Cool.
One from the gentleman over here.
I had a question about a concurrency. So I think I read the documentation that one cluster can have no more than 10 concurrent queries. How does that play into serverless? Do we have a concurrency limit?
Yeah, we do have the same concurrency limit. There's 10 concurrent queries. So if for example, they're completing very quickly, then we won't scale up another one. Instead, they'll be queued and completed very quickly. So it is the same limit in serverless and in classic SQL warehouses.
And one last one here.
Yeah, hi. A question about some of the TCO calculations. So will you be providing any kind of calculators to some of your enterprise customers? Maybe they can put their own enterprise licensing in there to help support that. It would help with kind of some of the overall TCO analysis if we're looking to make an adjustment on that.
Totally. So happy to work with you. Just reach out after the presentation. But we have a calculator that you can use. put your details of the workload, and that can help you also. The calculator will throw you numbers, how this will look like on Databricks or also on different competitive solution.
Thank you very much, serverless team.